Sizing and selecting a pump doesn't have to be a daunting process. With a basic understanding of some of the main considerations that you need to make, you'll be well on your way. We're here to help you with that first step. In this training module, we'll introduce you to the sizing and selection process to help you pick the right pump for the right job every time. Let's start by taking a look at the pump selection considerations. Throughout the pump selection process, there are a number of things you'll have to consider, such as the water source, where the water comes from, the volume flow, the sum of all outlets and consumption patterns, the total head, the vertical height from source to point of discharge, the power supply, what power is available to run the pump, and the control type, is it manual or automatic? We'll take a look at all these factors throughout the first part of this module. First up, the water source. There are a number of water sources including above-ground tanks, underground tanks, rivers, dams, lakes, boreholes, or mains water boosting. Once you've established where your water comes from, you need to consider whether the water is potable or non-potable, as that has a bearing on the application in which it can be used. Next, there's the flow, or Q. Flow is the amount of liquid that passes through a pump within a certain period of time. Volume flow is a critical parameter because we need to deliver a certain volume of water for a specific purpose. Typically, flow is measured in either cubic meters per hour, liters per second, or liters per minute. To work out how much flow is needed for the system, you must add up all the individual elements of the system. Head, or H, is measured in meters and depends on the density of the pumped liquid. As established earlier, the head is an expression of how high the pump can lift a liquid. When you buy a pump, the head that it can produce will often be specified. Next up, there's the power source. In order to select the correct motor for the pump, it is essential that you identify the power source. In domestic applications, the most common power sources include single-phase power, which is supplied by power companies to any homes connected to the grid, and generators, which are used as backups in remote or rural areas. Less common power sources include three-phase power, solar power, and wind turbines. Finally, you need to consider the pump control. There are two ways to control a pump, manually or automatically. As the name suggests, manually controlled pumps are completely manual, while automatically controlled pumps feature mechanisms such as float switches to turn the pump on and off. For the remainder of this module, let's turn our attention to the importance of sizing. If a pump is undersized, it has the following consequences. It won't deliver what the customer has ordered. It will have inadequate pressure. It will suffer from an insufficient flow rate. The system will be inefficient, and it will increase the risk of cavitation and pump failure. So, you might be thinking that you'd be better off oversizing just to avoid these risks. However, an oversized pump brings its own set of consequences that aren't any better. Oversizing means that your pump will use far more power than necessary. It will be much noisier. The velocity will be higher than required, and the pump may fail prematurely as it is operating far from its optimal efficiency. So, as you can see, undersizing and oversizing are pretty big issues. It's all about striking the right balance and finding the exact pump size for your needs. But how do we do that? Well, that's where pump curves come into play. First of all, in order to understand a pump curve, you need to know your system's characteristics. This is because a pump curve essentially is a pump performance curve showing the flow, Q, and total head, H. The system's characteristics show the pressure losses in the system as a function of the flow. When there's a cross point between the system's characteristics and the pump performance curve, you have the specific duty point. And once you've found your duty point, calculated your required flow rate and your total head, you will know which size your pump should be. That just about covers our module on sizing and selection. If you're interested in trying to size and select a pump yourself, head to Grundfos's Sizing and Selection tool, Grundfos Product Center.